This time, let's talk about Red Bull. In my last optimization video related to memory pools, I told you that in order to optimize memory pools, we now need a balanced binary search tree. And among many balanced binary search trees, I used the ABL tree. But in fact, it was said that there were many other forms besides the ABL tree, and one of them will be the RedBlack tree that I will explain today. Actually, the concept of RedBlack tree is really difficult. Therefore, it is a bit difficult for beginners to learn from the beginning, and those who have developed to some extent and become familiar with various data structures. I think it's a data structure to try. Okay, so let's get started. Yeah, basically, there are a few things, like rules, that you always have to meet at RedBlack tree.
Teeth.
Because this red and black tree is balanced by practically continuously following the rules. I think it would be the first thing to know in detail what these principles are. Yes, first of all, in the case of a red-black tree, there is a principle that all nodes must be composed of red nodes, if not black. In the next tree, we have something called the root node. This is always. There is a principle that it should be black. Also, now we will establish a parent-child relationship between trees like this, and when the red node is the parent, the child nodes must be black nodes. There should be no red node under the red node. Now, and these last riff nodes are usually called. This is now a concept that exists in this gen tree, so the bottom nodes in the tree we usually call riff nodes, and these riff nodes should always be black.
And
there is a nil node. What is this nil node? Now, like here. This is typically associated with the red node.
the price?
Let's assume it was worth 20.
And
20 practically.
that 20.
As a child, we said we didn't add any value.
Teeth.
To uphold the principle that all riff nodes should be black, we're adding a kind of ghost black node. And we usually call those ghost black nodes nil nodes, right? Now, I think this is going to be one of the most important principles. On this red and black tree, in any random place, let's say any location, for example, whether you start here or start here, the path to every mile node that you can reach from here. The paths to all of them must always have the same number of black nodes passing through them. For example, when we say we start here, there is one on the far left.
There are two.
The second one,
There are two.
one,
There are two.
one,
There are two.
one.
There are two, right?
As a rule, paths from any location to all reachable riff nodes must always pass through the same number of black nodes. Yes, so far I've basically explained this principle, and in the next video, what actually goes through when inserting data from this red-black tree. I will tell you if it will proceed.